Now, continuing further, we have found out the conditions for lines to be parallel. For parallel lines, what was the condition? A1 upon A2, or rather A1 upon B1 was equal to A2 upon B2. For perpendicular lines, perpendicular lines, what was the condition? A1 A2 plus B1 B2 was 0. Now, the third case is if the lines are intersecting. Obviously, perpendicular lines are also intersecting, but perpendicular lines is a special case of intersecting lines when the angle between them is 90 degree. But if the lines are just intersecting, they are not perpendicular, then the condition is A1 upon A2 is not equal to B1 upon B2. This you have already learnt in class 9. And the fourth condition, if the lines are coincident, that is both the lines are same, overlap each other, then A1 upon A2 will be same as B1 upon B2 will be same as C1 upon C2. That is, both the equations will be able to convert into single form. For example, if we have 2x plus 3y is equal to 4 and we have 6x plus 9y is equal to 12. Now if you look closely, what is A1? 2. What is B1? 3. What is C1? 4. Make sure C is either on the left side in both equations or on the right side. That is, they should be on the same side. A2 is 6, B2 is 9, and what is C2? 12. Now check, A1 upon A2 is 2 upon 6, 1 by 3. What is B1 upon B2? 3 by 9, which is again 1 by 3. And what is C1 upon C2? 4 by 12 is again 1 by 3. Therefore, these two lines are what? Coincident lines. And if you look closely, we can take 3 out. We have 2x plus 3y is equal to 12. 3 and this goes. Therefore, we are getting the same equation. Both the lines are same. That is, if lines equations are same, they will be one over the other. They will overlap each other. If the lines are intersecting, then we will find that A1 upon A2 is not equal to B1 upon B2. For example, if we have line 3x minus 4y is equal to 2 and 4x plus 3y is equal to 5. Now we want to find whether lines are perpendicular, parallel, intersecting or coincident. What should we do? We should find A1, A2, B1, B2, C1, C2. Now we can easily see that A1 upon B1 is not equal to C1 upon C2, or rather A2 upon B2. Therefore, lines are definitely not parallel. They are not parallel. They are definitely intersecting. They are intersecting. But now, if they are intersecting, are they perpendicular? So for perpendicularity, what should we do? A1, A2 plus B1, B2. We should find this value. A1, A2 is 12. B1, B2 product is minus 12. This is coming out to be 0. Therefore, definitely the lines are perpendicular to each other. This is how we can predict the nature of the lines, whether they are parallel, whether the two given lines are parallel or perpendicular or simply intersecting or coincident. Now let's take a few examples on this. Let's take the first question. Find the angle between the line joining the points 2, 0 and 0, 3 and the line x plus y equals to 1. So we are given two lines. One of the line is x plus y equals to 1. The other line is formed by joining these 2 points 2, 0 and 0, 3. So one way is to find out the slope of this line, which is m1. What is it? Minus coefficient of x upon coefficient of y, that is minus 1. And what is the slope of this line? We can use the 2-point form, y2 minus y1 upon x2 minus x1, which would be 3 minus 0 upon 0 minus 2, which is minus 3 by 2. Now, since we know m1 and m2, we can apply tan theta, m1 minus m2 upon 1 plus m1 m2. You can use m2 minus m1 or m1 minus m2. Since it is a mod, we'll get the same answer. This is method 1. Method 2 is we find the equation of the line. Let's say equation of the line AB. What would be the equation 2-point form? If you use 2-point form, y minus y1, let's say this is x1 y1. And let's say this is x2 y2. So what do we get? Y minus y1, y2 minus y1, 3 minus 0 upon 0 minus 2, x minus x1. What do we get? y equals to minus 3 by 2 times x minus 2. So we get 2y is equal to minus 3x plus 6, which is 2y plus 3x is equal to 6. Now this is the equation of the other line, and this was the equation of the given line. We can find a1, a2, b1, b2. What is a1? 1. What is b1? 1. What is a2? 2. What is b2? 3. We can apply the formula for tan theta. What was it? a1 b2 minus a2 b1 upon a1 a2 plus b1 b2. We can use this method also. But this is useful when both the equations are given to you. If you have to find the slope using 2-point form, then it is of no use first finding the equation of the line and then using this formula, because we can obviously find m2 and m1 straight away. This would be what? a1 b2 is 1 into 3 minus 2 into 1 upon 1 into 2 plus 1 into 3. This is 3 minus 2 is 1 and 2 plus 3 is 5. Therefore tan theta is what? 1 by 5. Therefore what is theta? Theta is tan inverse 1 by 5. Now let's take the next question. Find the angle between the lines x is equal to a and by plus c equals to 0. Now if you look closely, this equation does not require any formula or anything to be used. This can simply be solved by logic. X is equal to a is what? It is a line parallel to y-axis. This is distance a. This is parallel to y-axis. And what is y equals to minus c by b? by is equal to minus c. Therefore y is what? Minus c by b. These are constants. Therefore it is of the form y is equal to k. And this is a line parallel to x-axis. Wherever it might be above or below. This is y is equal to minus b by c. Now this is parallel to x-axis. Therefore what would be the angle between these two lines? The angle between these two lines would be definitely 90 degree. Angle between the lines will be 90 degree. Don't have to use any formula or anything of that sort. But if you want to actually use the formula, you can use this. X minus a is 0. We can write this as 1 into x, 0 into y, minus a is 0. Similarly, the second equation is 0x plus by plus c 0. What is a1? 1. What is b1? 0. What is a2? 0. What is b2? b. What is the value of a1, a2 plus b1, b2? a1 is 1, a2 is 0, b1 is 0, b2 is b. What are we getting? 0. Therefore, this was the condition for lines to be perpendicular. Therefore, lines are what? Perpendicular. Therefore, angle between the lines is 90 degree. Now, let's take the next question. If the lines y is equal to 3x plus 1 and 2y is equal to x plus 3 are equally inclined to the line y is equal to mx plus 4, then find m. Okay. Now what does the question say? Question says if there are two lines, this line and let's say this line. These two lines are equally inclined to a line y is equal to mx plus 4. Equally inclined means making same angle with the line. If this is theta, this is also theta. Let's say this is y is equal to 3x plus 1 and this is 2y is equal to x plus 3. Both these lines are making equal angles with this line. So obviously the angle between them is same. Therefore tan theta will also be same. We can write this equation as y minus 3x minus 1 is 0. And we can write this as 2y minus x minus 3 0. So what we have to do? We have to find, let's say this is line L1, this is line L2, this is line L3. So angle between line L1 and L3 is same as angle between line L2 and L3, which means tan of theta L1 L3 is same as tan of theta L2 L3, and which simply means we have to use a formula. What would be what was the formula between two lines? Tan theta was a1 b2 minus a2 b1 upon a1 a2 plus b1 b2. So what would be this angle? Tan theta L1 L3, L1 L3. Now we can convert this as y minus mx minus 4 is 0. This and this. So what is a1? Minus 3. What is b1? 1. For this line L1. And for L3, let's say this is a2 is minus m, and what is b2? 1. Now if we apply this, a1 b2, that is minus 3 into b2. What is b2? 1 minus a1 b2 a2 b1. What is a2? Minus m. And what is b1? 1 upon a1 a2, minus 3 into minus m plus b1 b2, 1 into 1. This angle should be same as angle between L2 and L3. This was your L2 and this was your L3. Now assuming this to be a2 b2, this is a1 is minus 1 and b1 is 2. So therefore a1 b2, a1 is minus 1. What is b2? 1 minus a2 minus m into b1 2 upon a1 a2 is minus 1 into minus m plus b1 b2, 2 into 1. These two angles should be, or since angles are equal, their tan value will also be equal. Therefore minus 3 plus m upon 3m plus 1 mod will be same as 2m minus 1 upon m plus 2. Now when the mod opens, it will open with both the signs. This is plus 1. 3m plus 1 plus minus 2m minus 1 upon m plus 2. So we'll solve them one by one, taking plus and minus signs. If we take the plus sign first, m minus 3 into m plus 2 is 2m plus rather minus 1 into 3m plus 1. What do we get? M square minus 3m plus 2m is minus m minus 6. This is 6m square plus 2m minus 3m minus m, and this would be minus 1. So minus m goes. This becomes 5m square equals to minus 5. But this is not possible because m square cannot be equal to minus 1. A square term cannot be a negative term, therefore this is not possible. Now if we take the negative sign, this is the positive sign. Negative sign, m minus 3 upon 3m plus 1 will be equal to minus 2m minus 1 upon m plus 2. On cross multiplying, we have m minus 3 into m plus 2 minus 2m minus 1 into 3m plus 1. So what we will get? M square minus m minus 6, and we'll get the same terms but with sign changed. Minus 6m square plus m plus 1. So this becomes 6m square plus m square, 7m square, and this becomes minus 2m, and this becomes minus 7. So what do we get? We get a quadratic. So what is m? Using Sridharacharya, 2 plus minus 4 plus 7 sevens are 49, 98, 196 upon 2 into 7. So this is 2 plus minus 200 upon 14, which can be written as 2 plus minus. This can be written as 200 can be broken as 100 into 2, that is 10 root 2 upon 14, which can be reduced as 1 plus minus 5 root 2 upon 7. Therefore what is the value of m? 1 plus minus 5 root 2 by 7. You could have also completed the question by finding m1, m2 by using the concept minus coefficient of x upon coefficient of y, and could have used the formula tan theta is m2 minus m1 upon 1 plus m1 m2. Either way you can get the answer.